Hey everyone. So in this video, I'm going to send you over to Jeremy, and he's going to tell you a little bit more about structs and objects in C and C++. So have fun. Peace.
Structs in C allows to organize multiple data types together into a new data type. In this example, this struct is a combination of two integers x and y with a character a in between. The layout of the struct in memory will simply place all of the characters, or all of the variables, one after another. If we compile this, run it, you see that the address of x, the address of a, and the address of y are all 4 bytes apart, which is the size of an integer. Everything in the struct will be aligned to the largest data type. In this case, it's an integer, so every single integer will be, every variable will be 4 bytes apart. Here we can modify the structs, like so. And we can, of course, get a pointer to the structs. For modifying and accessing pointers to structs, we use the arrow instead of the dot. Here we're making two different instances of the structs. One with 5, A and 6, the other was 7, B, and 8. obj1, of course, will be on the stack, and obj2 is created on the heap. The typedef keyword allows us to create custom type names. For instance, we can do typedef int hello. As you can see, the first value is 4. Because the data type of hello has been defined to be an integer by the typedef. We can also do the same with structs. So struct my struct now can say typedef struct my struct underscore t, and now the struct can be referred to via my struct t. And it works the same way. Classes in C++ are very similar to structs in C in that they are collections of data ordered a specific way. However, classes also allow us to bundle in functions with the class that are related to it and allow us to restrict how different variables and functions are accessed. Here I can define the following attributes as public and these as private. Public meaning that anyone can access it as long as they have a reference to the object, and private meaning that it can only be accessed by member functions. Here I can create an instance of the class in memory, because the class and the definition of the struct type is merely a template for how the object will be laid out in memory. This is actually creating an instance of that template in memory. Here I have two functions, set private variable and get private variable, and a private variable that is unable to be accessed outside of the class definition. I can define the functions for this class with the namespace operator. Every function that is a part of this class will be under the class's namespace. So the function name with the namespace of my class as is defined here. Here, as you can see, the class references itself to see its private variable using the pointer dereference operator here. And just like in structs with C, if it is created on the stack like this, we use the dot. But if it is behind a pointer, like with the new operator, which is effectively C++'s built-in malloc, then we would have to use the arrow. Okay, what? And as always, make sure that if you're compiling C++, that you use the C++ compiler. Now in C++, structs do not work the same way that they do in C. If I was to change this to struct, and recompile, it will work exactly the same. The difference being that by default, if I was to say make test in a struct, this is by default public. In a class, it is not. When instantiating an object, there are two functions that help create and delete all the necessary components. These are your constructors and destructors. Unlike regular methods, they do not have a return type and have the same name as the class. The destructor has a tilde placed in front. These also can be overloaded. Here there are two different constructors. Here, If we do not give a name in the constructor, then it will give a default name. Here it also uses the constructor to create a string object using new operator for a name. Here we create an instance of the class on the stack. And here is one that we create on the heap. If you see, it constructs two objects, one with a default constructor and one with a custom name. However, it only destructs the object with a default name. Because this object has been created on the stack, this object will be destroyed at the end of the function, as the stack is released back to the system. However, this one is created on the heap, and this object may persist after the function call is done, so there is no implicit call to the destructor. Here, now that we've created it with new and made a call to the constructor, we now need to call the destructor by using the keyword delete. And here, now we destruct both objects, one with a custom name and one with a default name. You can notice that the custom name object is deleted first, because it is deleted before the function call is over, which is when this object will be destructed. As a quick side note, there is a third way to instantiate an object, which is to use pre-allocated space. Now typically we would do this with malloc. However, there's a problem here. The constructor still needs to be called even after the data is allocated. The way to do this is by including new and then using the in-place call in order to make sure that the constructor is still called.